Okay, let's dive right in. For centuries, the way we design buildings has been tied to the materials we can use. But right now, we are in the middle of a genuine revolution. You see, 3D printing is doing more than just creating new things to build with. It's fundamentally rewriting the design process itself. It's letting us build structures that aren't just more complex, but are actually smarter. So let's break down how this technology is creating an entirely new blueprint for architecture.
But first, I have a question for you. Just look around. Chances are, the building you're in right now is basically a collection of boxes. It's all right angles, flat walls, and straight lines. Now, why is that? It's definitely not because it's the most beautiful or even the most efficient way to build. Nope. It's because for almost all of human history, it's been the cheapest and the simplest. Making anything with a curve, anything unique, has always been ridiculously expensive. Well, until now.
And this right here is the huge shift in thinking. The core idea is that, for the first time ever, making 1,000 completely unique, customized parts can cost the exact same as making 1,000 identical ones. That economic wall that kept our buildings in boxes for centuries, it's crumbling. And the most important takeaway is this: complexity is now effectively free.
Now, this newfound freedom, it's about way more than just making buildings look cool. It's really about performance. Architects can finally use the full power of computational design to create these incredibly intricate structures that were just physically impossible to manufacture before. We're literally breaking out of the box, designing forms that are driven by pure efficiency and purpose, not just by the limits of our tools.
But here's what's really fascinating. The biggest change isn't just the final building we see. It's actually happening behind the scenes, in the design process itself. We're shifting from this rigid, one-way street of designing to a dynamic, intelligent workflow.
So the old way, which you can see there on the left, was totally linear. Architects would design something, hand over a stack of drawings, and kind of cross their fingers that it could be built on time and on budget. But the new way? It's a conversation. It's a constant feedback loop, where the real-world facts of fabrication, cost, time, materials, and even how the thing's going to be put together on site, all of that information feeds back into the design right from the very beginning.
This whole concept is called the digital thread, and what it really means is that designers can make way smarter, much more informed decisions so much earlier in the process. They can know almost instantly how one tiny design tweak might affect the cost or the ability to actually manufacture it. It's a huge shift from designing for construction to designing with the knowledge of how it will be built.
Okay, so how does all this theory actually work in the real world? Well, it all comes down to one of the most brilliant and practical applications of this new workflow: reimagining the single most difficult part of any complex structure. Think about it. In any big building, especially one with a really complex freeform shape, the real headache isn't the straight beams or the flat panels. It's the joints, the nodes, the points where everything has to come together perfectly. These little connections are where all the geometric and structural complexity gets concentrated. Getting them right with old-school methods is incredibly expensive and insanely difficult. And here it is, the brilliantly simple solution. This is the big aha moment. You don't 3D print the entire building. That would take forever and cost a fortune. No. Instead, you use this powerful technology for one very specific job. You print only the most complex parts, the structural nodes. This slide just lays it out perfectly. On the left, you've got a single, incredibly intricate 3D printed node. See how each arm is angled with absolute precision for its own unique job? Then on the right, you see what happens. Thousands of these custom nodes connect simple, affordable, off-the-shelf bars to create this massive, lightweight, and stunningly complex pavilion. It's a hybrid approach, taking the absolute best of advanced manufacturing and combining it with the best of standard construction. So why is this such a total game changer? Well, first, it intelligently puts the cost and complexity only where you absolutely have to have it, in those nodes. Second, because every single joint is custom printed, it can be perfectly optimized by computer models for its specific role in the structure. This gives architects almost unlimited geometric freedom, all while fitting together perfectly with standard, affordable building parts. It's just smart. And this completely new way of thinking and building, it unlocks some very tangible, very real-world benefits. We're talking about structures that are smarter, more efficient, and a whole lot more sustainable.
This technology is really enabling two huge architectural trends to take off. On one side, you've got the performative trend, which is all about optimization, making buildings stronger, lighter, and way less wasteful. And on the other side, you've got the expressionist trend, which is all about artistic freedom, embracing these wild, complex shapes and even bringing back ornamentation in totally new ways.
Let's just focus on that performative idea for a second. The best way to get it is to think of a human bone, right? A bone isn't some solid, heavy block. It's this complex internal lattice, with material placed precisely where stress occurs. Well, that is exactly what structural optimization software does. It designs parts that use the absolute minimum amount of material needed for the maximum amount of strength, which creates these super efficient, lightweight, and often really beautiful organic forms.
And of course, that efficiency translates directly into sustainability. By putting material only where you need it, you slash waste, and the additive manufacturing process itself is more efficient, leading to anywhere from a 4 to 21% reduction in the energy used during production. Now, for the construction industry, that is a massive step forward.
So we've seen how 3D printing is already changing the game today, making complexity free and creating these smarter workflows. But honestly, this is just the beginning. The big question is, where does this all go from here?
This timeline gives us a pretty good roadmap. Today, right now, we're mastering these optimized joints and nodes. But in the near future, we can fully expect AI to play a much bigger role, generatively designing entire structures. A little further out, large-scale manufacturing will get cheaper and more practical, letting us print bigger and bigger pieces. And way out on the horizon, you can even imagine a future of assisted assembly, where digital information guides robots on site with unbelievable precision.
And this brings us to a final, really powerful thought. For all of history, our imagination as designers has been trapped by the limits of our tools. We built with straight lines because it was easy. But as those limits just fall away, the possibilities are expanding like crazy. So the question is no longer, what can we build? The real question now is, what kind of world will we design?